Hi everyone, in this video I want to do a graphing application problem. So it reads as follows. The occupation expected to have the most employment growth in the next few years is registered nurse. The number of people Y in thousands employed as registered nurses in the US can be estimated by the linear equation Y equals 22.2x plus 3097, where x is the number of years after 2019. Now, for our purposes, you don't have to worry too much about how they got this equation. But basically what we would do is we would take real world data from years past and graph it, see if we see a potential pattern there. So if it looks like the data is pretty linear, meaning that it's shaped like a line, we would then go ahead and use a linear equation to estimate that data set. And we can use the points that we already have in order to make an equation and help us make predictions. Now, the one thing that we do want to be careful about is you do want to be careful when making predictions. If you go too far outside the data range, then obviously things can change and differ from that answer, right? So we've seen in recent years, things come up such as the COVID pandemic, we've had recessions, et cetera, things that not everybody can plan for. So we do have to be careful when estimating data that we don't go too far, into the future, for instance. Or if we do, we really take that information with a bit of caution there and know that obviously things can change. So when we have equations like this, we would want to continually update them as new data comes into being, right? So in the next few years and so on as well. So the first thing we want to do is we want to graph this equation. Now, one thing I want you to note is that it says where x is the number of years after 2019, or sometimes we'll say since 2019. This is really important because this is a very common way to do time, particularly when we're talking about years, because when we do a graph, we don't really want to start our axis at year 0 and have to wait until, year 2019 or something like that to start plotting points. So what we'll often do instead is we'll say x is the number of years after 2019. So some values I'm going to plug in here because it doesn't really give me much direction. It just says to graph. Is I'm going to choose some simple numbers. I'm going to start with x is equal to 0 here, which actually would represent the year 2019 exactly, because x's are the years after 2019. So if my x is 0, that means I'm still in 2019. So I can take that value and plug it into my equation. Now, one thing I do wish I had known, because this problem does not give us a lot of background, is I'd really like to know when our data set started. That would kind of give me a better idea of, how much data has gone into this and so on, but I'm just going to use what they give me. So we're going to use x equals 0 here, basically as our starting point for years since 2019. Now, 22.2 times 0 is just 0. So my first point is 3097. So I have the point 0 for x, and then my y value will be 3097. Now, I do need a couple points here. And again, you can really pick whatever you want. I'm going to do x equals 2 as well. So 2 years after 2019. So this would be 2021. So I would do y equals 22.2 times 2 plus 3097. And you're just going to use your calculator here. Make sure you do order of operations. This would happen first. And then you would add it to the 3097. And you get 3,141.4. So I have another point, 23141.4. And again, I could find as many points as I wanted to. So I'm going to do 3 points here, but really 2 is actually sufficient for a line. And let's see, if I do 5 years, that would be 2024. Right? So I'm just doing 5 plus 2019. If you're not sure how I'm counting. So I'm just adding 5 years on there. So I would do 22.2 times 5 first. I plug that into my calculator. I already have the answer done here, and you get 3,208 for the total. So I have this first, and then I add it to the 3097. So I'm getting 5,3208. Now, the next thing you would do is you would obviously graph this. So I'm going to go to a text here and show you what the graph would look like. Let me just make some room. And you can see it right here. Now, when you're graphing an application problem, you do have a little bit of choices to make here. So one thing to note is the x-axis, we're using years after 2019. So we're not actually showing any data before 2019. I will say that that's actually kind of rare. So normally when we do real world applications like this, you'll see if you go into a little bit more higher mathematics, we do actually like to have, as much past data that's on there as possible, we usually also include. So when we do a lot of these real world applications, we do like to include even very beginning data. If our data started getting collected in like the 70s or 50s, whatever, we try to include as much as we can. So here we're doing it a little bit different. We're looking at more current predictions. And then on the y-axis, you can see that they chose values that seemed relevant for the information. Because our lowest value is 3097, I don't really need to have a lot of values below 3000. Your text is using a broken axis here, that little squiggle tells the reader that, hey, we are leaving off all the values below it, right? Because we don't really want to have a whole bunch of blank space from 0 to 3000. So that is used. It's okay to use with line graphs. It's not really okay to use with bar graphs, if I'm being honest, because it changes the ratios of the bars. But for line graphs, it's fine. You do have to be a little careful that you don't distort your data or cut off too much of the graphs. But this is pretty common when your data starts a lot higher than at 0. And then you can see the values that they've graphed, and they're just doing their best to estimate here. So 3097 is very close to 3100. At 2, you're at about 3141. And then at 5, you're at about 3208. So on the left here, they've decided to do their tick marks by 50s. So you'd want to think about, okay, what would be appropriate here to draw this graph? And that can vary from person to person too. So it does take a little bit of trial and error sometimes. Someone else may have counted by hundreds. Someone else may have counted by, I don't know, maybe 25s, right? So there's different ways to do this, but you want to kind of have a nice balance so that you can be accurate, but not have your graph be too cluttered. So the last part here is that we do want to predict the number of registered nurses in the year 2029. Now, the first thing to note here is that, well, 2029, if we're comparing it to 2019, let me just move this up a little bit, is a 10-year difference, right? 2029 minus 2019 would be 10. So your X value here is 10. That's really important to figure that out. So we're looking at an X value here of 10. And you can see that they already did that on the graph. So here's 10 years after 2019. If we scroll up to our equation and move to the left, we can estimate that it's probably around like 3,320 maybe, right? It's in between 3,300 and 3,350. So maybe 33, I don't know, like I said, 20 or something like that would be a good estimate there. Now, the other way that you can estimate it too is you also could actually plug the value 10 into the equation. So that does work as well. Just like we did these, if I plug in 10 here, I would do 22.2 times 10, which would be 222, and add that to the 3,097. And that would give us an estimate of 3,319. So in either case, though, they're both still estimates because we're going into the future. So I can't know for sure that that's actually going to be the value. So if I'm using the graph here, I'm estimating, or even if I use the equation in this case, I'm also estimating. And like I said previously, 2029 is a bit further into the future. So we do want to be a little bit careful that many things could change before we get to that point. So we do like to update our equations here as new data comes in, right? So if I have data for 2024, 2025, or 2026, I want to incorporate those and update this equation to better reflect that change. Maybe the change is going to increase and we need more nurses, or maybe it goes the other direction and we need fewer nurses, right? So again, as you're making predictions, you just want to be a little bit careful that future data is not guaranteed. So although we have a good estimate here of what we can expect or what we're planning for, that it may be different.